So we're going to go over the equations for these problems first. So the first equation is kind of a one. It's not hard, but it's once you see it, it's kind of strange. It's not something you've heard about before. So Rankine is like Kelvin for Fahrenheit. So on the Rankine temperature scale, 0 is absolute 0, but it uses the Fahrenheit degrees to go up. Does that kind of make sense? So temperature in Rankine is equal to what? Is equal to temperature in Fahrenheit plus 460. Alright, next one is for like the hydraulics you guys are using, and that's the pressure at one point in the hydraulic system is equal to the pressure at any other point in the hydraulic system. So if you have like your syringe, this is going to be terribly drawn up here, but it goes to the other one that's bigger. The piston and the piston. The pressure when you push down on this one is equal to the pressure over here, but the area is much larger on the large piston. So there you get a larger net force because it's force. The pressure is the same, area is larger, so you end up with a larger force. Does that make sense? It doesn't happen if they're the same size. So if they're the same size, they go up and down the same distance, they go up and down the same force. So if we rearrange this to say pressure is force over area, we can say force 1 over area 1 equals force 2 over area 2. And last equation we'll be doing here is the projectile one. So that's delta x for a projectile, so how far it goes horizontally, equals negative times the velocity squared times sine of 2 times the angle it's launched at, so 2 times theta is the launching angle there, over g. And it only works if it's going up and down to the same height. And g is going to equal either negative 9.8 meters per second squared or negative 32 feet per second squared. So depending on what units you have in the problem, you have to choose which one of those to use. Does that make sense? So if you have distance in feet or velocity in feet per second, you use 32. If you have distance or velocity in meters, you use negative 9.8. Any questions on those equations? Velocity. So how fast it's coming out of the cannon. That is velocity initial. So that's how fast it's going initially. Alright, what is the temperature in Rankine when it is 52 Fahrenheit outside? The degree didn't work on the, so 52 degrees. So it's just going to be temperature in Rankine equals temperature in Fahrenheit plus 460. So equals 52 plus 460. And what's the temperature in Rankine going to be? There's a degree with Rankine. Why would you use Rankine? If all your stuff is in Fahrenheit and you need to use an absolute temperature, like for like gas laws or something like that, it's much easier just to go to Rankine than to like go through to Celsius to Kelvin. Right. A piston with a radius of 13 inches is used to lift something on a piston with a radius of 54 inches. How many pounds of force are required on the 13-inch piston to lift 290 pounds on the 54-inch radius piston? Alright, so this is going to be, we're going to use F1 over A1 equals F2 over A2. But what do we need to do before we can use that equation? Find the area. So we'll say area 1 is going to equal, how do we find the area if we have the radius? Pi r squared. So it's going to be pi times 13 inches squared. And what do we get for our first area? And not in terms of pi. 130.9 inches squared. Area 2 is going to be pi r squared again. equals pi times 54 squared. And what do we get? That's inches squared. So now we do F1 over A1 equals F2 over A2. So we've got area 1 is 530.9 equals area 2 is 960.9. Does the 290 pounds, does that go with, is that F1 or F2? F2, because that's on the 54-inch radius piston, so 290 pounds. Then you cross multiply and divide, and what do we get for the force you need to apply on the smaller piston? And you have to apply less force. What are you sacrificing to that area? You have to push the smaller piston down further to lift it up the same amount. Any questions on that one? Alright. Projectile is launched at ground level with an initial velocity of 44 feet per second, angle 37 degrees above the horizontal. How far horizontally did the projectile travel? So we use that delta x equals negative v squared times sine 2 theta over g. And we're looking for delta x, so we're going to say negative 44 squared times sine of 2 times 37 over, which g are we going to use? Yep, so negative 32 feet per second squared. When we do that math, we get you should remember, if it's not supposed to be a negative number, because you should have a negative here and a negative here. 58.2, so that's more reasonable. That's 58.2 feet. And again, just remind, make sure you're in degree mode in your calculators. Any questions?